The next type of data visualization that we want to talk about are pie graphs and pie charts. Pie graphs and charts are a circular statistical graphic which is divided into slices to illustrate numerical proportions. The area of each slice is proportional to the quantity it represents. Example 3 says, below is a pie chart that depicts the percentages of time a person spends on their smartphone in different categories. Use the chart to answer the questions below. Part A says what percentage of time is spent on news or games. So we want to find news here and we want to find games here. And news is 6% of the total time and games are 30% of the total time. So to answer this question, we would add those two percentages together. So 6% plus 30% equals 36%. So we would say 36% of time spent on smartphone is spent on news or games. Part B says, if this person spent a total of 5 hours and 48 minutes on their smartphone, how much time did they spend on social networking? So here's the social networking, and that is 24% of their total time. And let's see, if that person spent a total of 5 hours and 48 minutes, how much time did they spend on social networking? So the first thing that I want to do is I want to convert this 5 hours into minutes so that our total time is changed into minutes. So we know that 1 hour is equal to 60 minutes. And so 5 hours, we would just multiply 60 by 5, which would give us 300 minutes. And so if we add the 48 minutes to that, then we would get that 5 hours and 48 minutes is equal to a total of 348 minutes. So now that we have converted our time completely into minutes, now we want to take 24% of that. And remember, a lot of times when we hear the word of in the context of some kind of like word problem, most of the time that indicates that we want to do multiplication. So 24% as a decimal is written as 0.24 of 348. So we want to multiply those two numbers together. So 0.24 times 348 is 83. I'm going to go ahead and round that to 84 minutes. So they spend about 84 minutes or 1 hour and 24 minutes on social networking. A histogram is the name given to a bar graph for numerical data. The vertical scale on a histogram could be frequency, relative frequency, or density. Example 4 says the histogram below shows the response times of various 911 calls. Use the histogram to answer the questions below. So I kind of want to just emphasize again, the difference between a bar graph and a histogram is that a histogram, if you look at this axis here, these are represented by numbers. And so because there's infinitely many numbers, what we do is we chunk them into what we call intervals. So the first interval is between 1 and 5. Now, because this represents a response time, that could be an infinite number of things. It could be 1 minute, it could be 1 minute and 20 seconds, it could be 1 minute and 40 seconds and 2 milliseconds, it could be 2 minutes, 2 minutes and 30 seconds. So really there's infinitely many values within each of these intervals. So that's why we have these intervals versus if we were measuring categorical variables. For example, if I was measuring dog breeds in like a state, if I had like a Chihuahua and maybe like a German Shepherd, and some other ones. I'm trying to think of a dog right now. Golden Retriever. So if I was measuring these things, it's just, there's only it's just a golden retriever or just a chihuahua, and these are representing different heights or things like that. Whereas numerical variables, within each of the intervals, there's infinitely many values there. So we have to look at a range or an interval of values. So how we read this is that if we look at this first bar here, there were 5 911 calls that the response time was somewhere between 1 and 5 minutes. And then let's read the next bar chart. So if we look at this bar, this is 11. And so that means that 11 out of all of these 911 calls, the response time was somewhere between 5 and 9 minutes. And then the most common response time was somewhere between 9 and 13 minutes. And out of all of them, let's see, that looks like 23. So there were 23 911 calls where the response time was somewhere between 9 and 13 minutes. So let's go ahead and fill out the rest of these values. So between 13 and 17, it looks like there was 14. And then here there were 9. And then the last grouping, there were 4. So I'm just going to quickly add those up. So we have 5 plus 11 plus 23 plus 14 plus 9 plus 4. Okay, so there were looking at this data, we are analyzing 66 911 calls or 911 call response times. But the important part is that there's 66 of them, and we will use that later in just a moment. So part A says, which class contains the first quartile, the 50th percentile, and the third quartile? Now, if you don't know what quartile means, if you look at this word, the first part is quart, and quart, maybe you can think of a quarter, like the money, or quarter like 1/4. But basically, the first quartile is the place where it separates the lower 25% of the data to the upper 75% of the data. So one way that we could think about this is if we took 66 and we took 1/4 of it, or 25%, however you want to think about it. So 1/4 or a quarter of 66 is, well, taking the quarter of something is the same thing as dividing by 4. So I'm going to divide that by 4. And so that is equal to 16.5. And so we want to think about the groupings. So if we added these first two groups, there are 16 here. So that's not going to contain the first quartile. And if we added this next one, so 16 plus 23 is 39. So the first two bars, if we added them up, there are 16 people within those two categories. But we want to be at 16.5. So the first quartile is in this interval. So I'm going to say 9 to 13 contains the first quartile. Okay, the 50th percentile is like the median, basically. It separates the lower half from the upper half. So we have 66 people, And if we took half of that, half of 66 is 33. So basically we want to find the interval that separates the lower half of the cases from the upper half. And we said that the interval from 9 to 13, I erased it, but we have, let's see, 23 plus 16 is 39. And so if we were to go higher, we're already looking for the interval that contains 33 people, basically. But if we add the first 3 bars together, there are 39 response times or 911 calls there. And so that means that the median is also going to fall within that interval. So 9, 13 contains the 50th percentile. Okay, it's probably not going to be the case that it contains the third quartile. The third quartile is the where basically the lower 75% is separated from the upper 25%. And the way that we can do that is we could multiply or take 75% or 3/4 of 66. So if I did that, if I multiplied 3/4 times 66, that would be 49.5. So I want to see which interval contains 49.5. So if I add the first 4, that would be 39 plus 14, which is 53. So if we include the first 4, that would be 53 response times. And just the first 3 is 39 response times. So 49.5 falls somewhere between there. And because it's happening when we add this bar, it's going to be the third quartile is going to fall somewhere in there. So 13, 17 contains the third quartile. So those are the answers for part A. Part B says, what proportion of response times took more than 17 minutes? I'm just going to do some quick erasing. So here is 17 on our horizontal axis, and this bar contains 9 and this bar contains 4, so that means that if I added those together, 9 plus 4 is equal to 13. So that tells us how many response times were more than 17 minutes, because 9 of the response times fell between 17 and 21 minutes, and 4 of the response times fell between 21 and 25 minutes. So in total, there were 13 response times that took more than 17 minutes, and it's asking for what proportion. So we want to take that 13 and we want to divide it by the total, which was 66. And so 13 divided by 66 is about 19.7%. So about 19.7% of response times took more than 17 minutes. This last page just contains some of the definitions of the quartiles or percentiles that we were talking about earlier. So go ahead and read over those and see if you have any questions about percentiles or quartiles.